Okay, so in the previous unit, when we talked about how to multiply and divide, the strategy that we used was expand. And so what we would do is, instead of like using any kind of rules, we would expand them and then multiply or expand and then cancel. So for example, for this one, the area of a parallelogram, so the area is length times width. Okay, so I would say 3n squared r, well, I'm sorry, base times height, 3n squared r times 5n squared r. And then what I would do to combine that is I would make a group for each of these different things, right? So I have numbers, n's, and r's. So I'd have 3, and then I would expand those that n squared. So instead of writing n squared, I'd write nn. And then I have an r over here. And then I would do the same thing here, times 5 times nn times r. And then I would combine them together. 3 times 5 is 15, and n is n to the 4th, r is r squared. So that's how I would multiply that. When I divided, I would kind of do the same thing, except I would group them up top and bottom. So I have tens, I have numbers, x's, y's, and z's. So I'm going to make 1, 2, 3, 4 sets of parentheses. Okay. On the top, I have a 10, I have an x, I have 4 y's, oh my gosh, and 5 z's. Kind of almost went outside my little parentheses there. And then over on this, on the bottom, I have 5. I have no x's, but I've got 2 y's and a z. So now when I look, I'm going to start canceling stuff. So 10 divided by 5 is 2. And then I have an x. And again, this is all on the top. My y's, I can cancel 2 of my y's, and then I've got 2 y's, which is y squared. I can cancel 1 of my z's, and I've got 4 z's, which is z to the 4th. There's nothing on the bottom, so I have 2xy squared z to the 4th. And again, the reason why I put a 1 down there is because if there's nothing left on the bottom, we put a 1, and then that's one of my invisibles, so it will eventually disappear. So that's how we did it before, like when we learned how to, first started learning how to multiply and divide with this type of expression. Well, now we're going to learn some rules. So what we're going to do real quick is I'm going to model I'm going to model a couple of them for you, and then I want you to try these, try the last ones. Okay, so I'm going to model, well, I'm going to model a couple of them for you. So, okay, so if I look at this, I have a times b. So if I look at that, so that's an expanded form. So what did they expand that from? Well, they expanded it from a squared b. That's the first one. And the second one is a times b times b times b, which is a times b to the 3rd. Okay, so a times b to the 3rd. So that's what it expanded to. Now, if I use this, I have 1, 2, 3 a's, a to the 3rd. And I have 1, 2, 3, 4 b's, b to the 4th. Now, let's look at this and see if we can figure out how they got there. Well, I know that a squared went to a to the 3rd. Like all the a's went to the 3rd, the b's went to the 4th. So maybe I just added 1? I don't think so. Are there any invisibles that I can write? Well, I can put an invisible there next to those ones that don't have an exponent. I can put an invisible 1. Well, now I've got a squared and a to the 1st. Maybe there's something there. Okay. Let's try this one. This one goes the other way. Okay, so now I have, if I expand it, I have a, b, b, b times a, b. Again, all I did was I wrote down that many. Just a real quick reminder, let's take a slight detour. When we talk about quadratics and we talk about numbers like this, we have different, let's remember the parts of an exponent, okay? So we have, let's say we have like a to the m, okay? This is my base, and that is my power, okay? So I take my base and I raise it to the power, okay? Now, if I want to point something out. Am I combining things that don't have the same base? Did I put A's and B's together? No, I did not, because that would be like combining like terms. I can't they're not BAs, they're A's and B's. So they have to have the same base. And so in this case, A is my base. And for me to be able to combine them and, combine them into a base raised to a power, they have to have the same base. Okay? So if I look here, I have 1, 2, 3, 4 A's, so I'm going to be A to the 4th. And I have 1, 2, 3, 4 B's, so that's going to be B to the 4th. If I put my invisible 1 there, what I'm seeing is I have A squared and A squared, which makes A to the 4th. Seems kind of like I'm adding. B to the 3rd, B to the 1st equals B to the 4th, kind of like I'm adding. Okay? Let's try this last one, and then I'm going to let you try these last two, and I'm going to have you give me simplified forms for both of those. Not the originals, but the the new forms. Okay, let's try this one. This one's going to be a little different, because this one I'm going to have stuff on the top and the bottom. So for this one I have A, B, 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 because there's 1, 2, 3, 4, 5, 6, 7 B's, because it's B to the 7th. Okay, I have a base of A, but there's only one of them. I have a base of a B, and there's 3 of them. Okay, and since these are division, I'm going to cancel. So I'm going to cancel an A with an A. I'm out of A's. Now I'm going to do a B, and a B, and I'm out of B's on the bottom. So now what I have left is I have A, and I can say A to the 1st, but I don't have to write that one because that's one of my invisibles. Remember, I always have invisibles. I have 1 A to the 1st over 1. So all of these invisible ones, I can use them when I need to. If I need a coefficient, I put a 1 there. If I need an exponent, I put that little 1 exponent. If I need a number, a denominator, I put that 1 underneath it. So that's my invisible 1. I can use it or I don't have to. And I've got B 4 times, so that's going to be B raised to the 4th power. Okay? I want you to try numbers 4 and 5, and I want you to tell me what you got for those answers. Okay, so I want the simplified answer. So I can look at this right here and see what the simplified answer was. I have A, which means A to the 4th. And I see B, 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 which is B to the 3rd. Over here, I see I can cancel an A and cancel another A. I can cancel a B. Well, what's left is B squared on the top and nothing on the bottom, so I put a 1. Remember, if there's nothing on the bottom, I can put an invisible 1 down there, okay, which simplifies to B squared, okay? Now, if I wanted to see what those had been written right before, I have A twice, which means I have A raised to the 2nd power times B, and if I want to put the invisible 1, I can, but I don't have to. In fact, you won't usually see the invisible 1. And then on the next one, I have A to the 2nd power, B to the 2nd power. Same thing with this one. On the top, I have A raised to the 2nd power, B raised to the 3rd power, A raised to the 2nd on the bottom, and B raised to the 1st, or, I don't have to put that if I don't want to. Okay, so what we should be noticing, what you should be starting to notice is that I could do all this work of expanding, or I can look at the exponents. If I have A squared and A to the 1st, that means I have 2 A's and 1 A, and I raise them to this. If I combine them, I'm going to have 3 A's, so A raised to the 3rd power. So when I'm multiplying powers, if the bases are the same, which means my A or my B, so whatever's being raised to the power has to be the same. If they're the same, then all I do is add the exponents. Okay? So I want you to try this first problem, example 1. Okay, so A to the 3rd times A to the 5th is A to the 3 plus 5, because again, since they have the same base, I can raise them, I can add these up. When I add 3 plus 5, I get A to the 8th power. Okay, these are multiplication signs. Okay, so I'm sorry about that looking weird. Okay, so I'm going to do this one with you, and then I'll have y'all, at least I'll set up the first part. I'll have y'all do the next one, okay? So they start by taking 3 times 2, and they put that here, so almost like that's in parentheses, times n. So how many n's do I have? Well, in the first part, I have n to the 7th. The second one, I have n to the 4th. For my r's, I have r to the 3rd. And then don't forget, even though you don't see an exponent here, it's r to the first. This is where you guys are going to make a mistake. You're going to see no exponent and think you don't have to add anything. But if you don't see an exponent, its exponent is 1. Now, I don't see any x's here, but I do see 1x raised to the second power here. So then I'm going to combine everything. I'm going to do 3 times 2 is 6. N to the 7 plus 4 is 11. N to the r to the 3 plus 1 is 4. And x to the second stays x to the second. Okay? I want you guys to try example 3. Okay, so x to the a times x to the b times x to the c is x to the a plus b plus c. Okay? I know these are kind of hard to write, but on Edpuzzle, but you know, there it is. Okay, so that's how we multiply. That's the product. Product means multiply. That's the product of powers. And we're going to take some notes, and on this tomorrow in class, we're going to put them in an organizer so that we can kind of see them more easily. Now, quotient means dividing. The quotient is the answer to a division problem. So if we look at this problem here, number 5, when I had a to the 2 over a to the 2, what happened to those? They canceled out because 2 minus 2 is 0. I wound up with 2 b's over here because 3 minus 1 is 2. So when I'm dividing powers, if the bases are the same, then we subtract. We subtract the exponents, okay? So if the bases are the same, so my a's, I can do a to the 2 minus 2 is a, that just goes away. B to the 3 minus 1 is b squared, and that's all that was left. Okay, I want you to try example 1. A to the 5 divided by a to the 3rd. Okay, so when I have a to the 5 over a to the 3, since I'm dividing them, I'm going to subtract those exponents. So I'm going to have a to the 5 minus 3. Well, 5 minus 3 is 2, so a to the 5 divided by a to the 3rd is a squared. Okay? I want you to try this one. Again, you're going to use that same rule. And just as a reminder, if you don't see an exponent, what do we put next to it? We put a 1. So even though this just looks like a regular 3, we can put 3 to the first there as well. Okay, I want you guys to try this problem. Okay, so I have 3 to the 4th minus 3 to the 1st, because I'm dividing them, and I look at the bases, the same bases, y and y, so I have y to the 5th minus y squared, and that gives me 3, because 4 minus 1 is 3, 3 to the 3rd, y to the 5 minus 2 is y to the 3rd. Okay? And then this last one, again, is the same thing. Y to the 7 to the x over 7 to the y is 7 to the x minus y. Okay? So that's the first 2 rules that we're going to learn. All right? Now, I want you, when this video is over, I want you to do these problems. I'm going to encourage you strongly to do them. And if you don't, you're going to regret that choice. Okay? So you're going to do these when this video is over, and we'll talk about them tomorrow. Okay, so let's look at this one. Let's try this one. Okay, so this is going to lead us to our next rule. Okay, 15 squared over 15 squared. Using my rule that I just learned about quotients, which is division, when they have the same base, I divide. I subtract the exponents, right? So that's going to be 15 to the 2 minus 2, which is 15 to the 0. Okay? You see where I'm going there? 47 to the 4th over 47 to the 4th is 47 to the 4 minus 4, which is 0. 4 to the 3rd over 4 to the 3rd is 4 to the 0 power. 1390, whatever that number is, 1739 squared over 1739 squared is 1739 to the 0. Negative 32 squared over negative 32 squared is negative 32 to the 0. Negative 32 to the 5th over negative 32 to the 5th is negative 32 in parentheses to the 0 power. Okay? So, we're going to do this part together because I know a lot of y'all don't have calculators. So all I'm doing is putting these values into my calculator. Okay, that's all I'm doing. I'm not actually going to be, so I'm putting them in. So I want to remind you, though, that when we use the calculator, when we want to raise something to a power, we're going to use this button right here, this up arrow. Okay? So let me zoom out a little bit so you can see that while I'm entering it. Okay? So if I want to do the first one, I'm going to do 15 raised to the 0 power. And when I do that, I get 1. Let's try 47 raised to the 0 power. I get 1. And again, these are the answers that we got here. We're just working them out now. Now I got 4 to the 0 power, and I got 1. What do you think 1739 to the 0 power is going to be? So the 0 is 1. Now, these two I want us to look a little bit more closely at, because for these two, they're going to be a little different, because remember how when we raise stuff to, when we squared something, we get a different answer when the negative is outside the parentheses than when it's inside? Let's look at what happens in this case. So I have negative 32 raised to the 0 power. I get negative 1. Okay? And then when I do, in parentheses, negative 32 raised to the 0 power, I get positive 1. Okay? So, why do you think that is? Write down for me why you think that is. Okay. Well, the reason for that is because, remember, order of operations. Remember PEMDAS, our good friend PEMDAS? Says that we do exponents before we multiply or divide. Changing the sign of something is treated like a multiplication or division operation. So I raise it to the power first, and then I take the opposite of it. So this is saying I'm going to do my exponent first, and then I'm going to multiply. On this one, everything's inside the parentheses, so when I raise it all to the 0 power, it becomes 1. Okay? So what do we notice about things raised to the power of 0? What is their value? They are equal to 1. Okay? So they're equal to 1. So let's try one more. 0 raised to the 0 power. We get an error that says domain. Okay? This gives us an error because, let's write this down. Let's turn this into a subtraction problem. Okay, or a division problem. So let's say, how could I get 0? I could subtract, so in all of these were like raised to the second or the fourth. So I could give it an exponent. Let's say I had 0 to the third. If I want to make my exponent 0, I do like 3 minus 3. You kind of see what I'm saying? So does this equal 0 to the 0? Because I have 3 minus 3. What kind of problem is this when I'm subtracting? So when I look at my two rules over here, okay, when I'm multiplying, I add them. When I'm dividing, I subtract them, right? So if I'm dividing, I subtract. So this is a division problem. And I'll talk about this more tomorrow, but I kind of want to just give you a brief explanation. So if I rewrote this as a division problem, I would be writing 0 to the 3 over 0 to the 3. Okay? Okay, so let's just work it out. 0 to the third power is 0. 0 to the third power is 0. Does anybody remember what's wrong with this? I had this on my board for a while. It'll be up tomorrow when you come in. Do you remember this? Don't remember that? You can't have a 0 on the bottom. It is not okay to divide by 0. Anytime you're raising 0 to a power, anytime you raise 0 to the 0 power, you're ending up with a situation where you have a 0 on the top and a 0 on the bottom, which means you have a divide by 0 error. Now it says error domain because it's saying you're giving it an input that it can't do. But what it really means is you're telling it to divide by 0, and that's why it doesn't work. So 0 divided by 0 is error. I think it's error domain, which again means divide by 0. In this case, it means you're dividing by 0. So what that means is when we write this rule for the power of 0, any non-0 number, so this works for anything as long as it's not 0, raised to the power of 0 is 1. Okay, I'm not sure what this example 3 is. We're not going to do that. I want you to try example 1. You don't even need a calculator for it. What is 3.4 raised to the 0 power? 1. Try example 2. What is 422 raised to the 0 power? 1. Now, just for grins, let's try Mrs. Deal's example 3. Negative 26 raised to the 0 power. That is negative 1, because 26 raised to the 0 power is 1, and then I take care of the which makes it negative 1. What about this one? Negative 16 raised to the 0 power. Well, since it's in parentheses, I take negative 16 raised to the 0 power, and I get positive 1. All right. Tomorrow we're going to put some notes in our notebook. You're going to need to keep these notes. Make sure you don't forget to do this part on the top, and then we're going to take some notes and get ourselves a graphic organizer going in class tomorrow.